Meet Marcus. He's in 6th grade, and his teacher just handed out a worksheet on prime factorization. Marcus stares at the number 60 and thinks, how do I even start? Sound familiar? Here's the secret. Every number is built from smaller pieces, kind of like Lego bricks. And today, we're going to learn exactly how to find those pieces. By the end of this video, Marcus and you will be able to break apart any number like a math detective. Let's go. Before we can do prime factorization, we need to know what a prime number actually is. A prime number is a number greater than 1 that can only be divided evenly by 1 and itself. That's it, just 2 factors. So 2 is prime, 3 is prime, 5, 7, 11, 13, all prime. But 4 is not prime because 4 equals 2 times 2. It has more than 2 factors. Think of prime numbers as the atoms of math, the tiniest building blocks that can't be broken down any further. Marcus highlights all the primes on his number chart and is starting to see the pattern. Okay, so prime factorization means breaking a number all the way down until every piece is a prime number. Imagine you have a big Lego creation. Prime factorization is like taking it apart, piece by piece, until you're holding nothing but the individual bricks. For example, 12 can be written as 2 times 2 times 3. Those are all prime numbers. You can't break them down any further. We call this the prime factorization of 12. Marcus just wrote this on his worksheet and his eyes lit up. He gets it now. Every number has its own unique set of prime building blocks. There are 2 great methods for finding prime factorization. Let's start with the factor tree. It's the most visual and Marcus's personal favorite. Here's how it works. Write your number at the top, then branch it into any 2 factors. Keep branching each factor until every branch ends in a prime number. Those prime numbers at the bottom of the tree? That's your answer. The cool thing is you can start with different factor pairs and still get the same prime factorization in the end. Math is consistent like that. Ready to try one with Marcus? Let's build our first factor tree together. Here's another method called the division ladder, and some kids actually prefer this one because it looks super organized. You start by dividing your number by the smallest prime that goes in evenly, which is usually 2. Write the result below, then divide again. Keep going step by step until you reach 1. Then read all your divisors from top to bottom. Those are your prime factors. Marcus tried this method after finishing the factor tree and said it felt like going down a staircase of numbers. Both methods give you the same answer, so use whichever feels more natural to you. Here's where it gets really cool. When you have repeated prime factors, you can write them using exponents instead of listing them over and over. For example, 2 times 2 times 3 times 3 can be written as 2 squared times 3 squared. That's so much cleaner. This is called exponential form, and your teacher probably wants you to use it. The base is the prime number, and the exponent tells you how many times it appears. Marcus was so excited when he learned this. It made his answers look like real math textbook equations. Let's see it in action on some examples. Okay, this is the exact problem Marcus had on his worksheet. Let's find the prime factorization of 60 using a factor tree. Start with 60 at the top. Let's split it into 6 times 10. Now branch 6 into 2 times 3. Both prime, so those branches stop. Now branch 10 into 2 times 5. Both prime, those stop too. Collect all the leaves at the bottom, 2, 3, 2, 5. Let's put them in order from smallest to largest. 2 times 2 times 3 times 5. Now check. 2 times 2 is 4, times 3 is 12, times 5 is 60. Yes, in exponential form, the answer is 2 squared times 3 times 5. Now let's use the division ladder for 48. Marcus tried this one next and loved how neat it looks. Start with 48. Is it divisible by 2? Yes. 48 divided by 2 is 24. Is 24 divisible by 2? Yes. 24 divided by 2 is 12. Is 12 divisible by 2? Yes again. 12 divided by 2 is 6. Is 6 divisible by 2? Yes. 6 divided by 2 is 3. Now, is 3 divisible by 2? No. Try 3. 3 divided by 3 is 1. We've reached 1, so we stop. Our prime factors are 2, 2, 2, 2, and 3. That's 4 2s and 1 3. So 48 equals 2 to the 4th power times 3. Let's verify. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. Correct. Let's tackle 90 together. This one has 3 different prime factors, which makes it extra interesting. Marcus's teacher put this one on the board as a challenge. Let's use a factor tree. Split 90 into 9 times 10. Now branch 9. That's 3 times 3, both prime. Branch 10. That's 2 times 5, both prime. Collect the leaves. 3, 3, 2, 5. Reorder smallest to largest. 2 times 3 times 3 times 5. Check. 2 times 3 is 6, times 3 is 18, times 5 is 90. Perfect. In exponential form, that's 2 times 3 squared times 5. Marcus pumped his fist. 3 prime factors, and he nailed it. Ready for the next level? Let's try 252. This is the kind of problem that shows up on 6th grade tests. Use the division ladder. 252 divided by 2 is 126. 126 divided by 2 is 63. Now, 63 is not divisible by 2, so we try 3. 63 divided by 3 is 21. 21 divided by 3 is 7. And 7 is a prime number, so 7 divided by 7 is 1. We stop. Prime factors: 2, 2, 3, 3, 7. Check. 2 times 2 is 4, times 3 is 12, times 3 is 36, times 7 is 252. Yes! So 252 equals 2 squared times 3 squared times 7. Marcus could not believe he just factored 252, and neither can you. Before we wrap up, here are Marcus's favorite tips for prime factorization. First, always start with the smallest prime, which is 2. If the number is even, 2 goes in. Second, use divisibility rules. If the digits add up to a multiple of 3, then 3 goes in. For example, 63. 6 plus 3 is 9, and 9 is divisible by 3, so 3 divides 63. Third, once you get to a prime number on the ladder, you're done. Fourth, always double-check your answer by multiplying the prime factors back together. If you get the original number, you nailed it. These shortcuts will save you tons of time on tests. You might be thinking, okay, this is cool, but when do I actually use this? Great question. Prime factorization is the foundation for finding the greatest common factor, or GCF, and the least common multiple, or LCM, which you'll use a ton in 6th and 7th grade math. It also helps with simplifying fractions. And in algebra, you'll use factoring all the time. Marcus realized that this one skill unlocks a whole bunch of other math topics. Think of it like learning to ride a bike. Once you've got it, everything else opens up. Parents, this is a great concept to practice together at home. Remember when Marcus was staring at that worksheet, completely stuck on the number 60? Look at him now. He's breaking apart 252 without even blinking. Let's recap what we learned today. A prime number has exactly 2 factors, 1 and itself. Prime factorization breaks a number into its prime building blocks. You can use a factor tree or a division ladder. Both work great. Write repeated factors using exponents for the cleanest answer, and always check by multiplying back. You now have a seriously powerful math skill. Practice with a few numbers tonight. Try 36, try 100, try 180, and you'll be a prime factorization pro in no time. You've got this.